to go. And we'll begin. And again, congruent figures, basically order matters. Look at your congruency statement. Because the homework assignment that was actually due next class, the first part of your congruency statement, that's going to tell you what you have to do for like the second part of your congruency statement. So basically you have to follow that order. So now, on the next page, so this is going to be the top of the next page. These are the four big ones. The side, side, side. All three sides are going to pair up. Side, angle, side. Two sides are going to pair up with an angle in between. Angle, side, angle. Two angles are going to pair up from one triangle to the other with the side between the two angles. And then also you have angle, angle, side. It could also be side, angle, angle. I will take that too. I will accept it either way. Those are the four big ones. Okay, we don't need that. And then hypotenuse leg, which I know on the homework assignment you saw this a little bit. This one's probably going to be the least popular of the five, but it's still there. So these, but we've seen all these in one way, shape, or form from before. Now, what we're going to do, in a little bit. Maybe this one, but definitely with the other four. You're going to get two parts. So I'm going to give you two triangles. You're going to get two parts of the triangle. But then you have to determine the third part that would make this congruence hold up and be true. So we sort of talked about it the very end of last class, but we ran out of time. So if you have brought your package from last time, okay. If you did not, don't worry about it, because the slides that we didn't do from last time, we're going to cover that first thing today. So I figured let's just cut to the chase. What we missed last time, we're just going to cover right away today. Okay? And then we also talked about the shared side. We started talking about that last time. So the shared side, you may have to break off your diagram into two triangles. So for instance, with this one right here, you'd have to break it off like that. I know it's not drawn to scale. And then notice the shared side. They're always going to be congruent. They'll always be congruent, the shared side from one triangle to the other. Similarly, this one, although this one you're not going to see as much on your test, you're going to probably see one that looks more like this, or it's going to look, I don't know if I can get it. Yeah, that's not the best one. Hold on, let me see something. This is the one. Or it might look like this, where there's your line. So that would be like A, B, C, D, but then it splits up. A, B, C. A, C, D. So I'm just going to delineate our diagrams here. So you're going to probably see ones that look more like these two. Not so much this one. So I just want everybody to see. But again, the shared side, look which side has common letters. So for when you break up this triangle, A and C, those are the common letters. And then also, we'll talk about this one where our angles, the alternate interiors, they're congruent as well. But we'll talk about that angle stuff more in a little bit. But the goal is, especially where the two triangles, they get joined up, you have to look at which side is common on both sides for both triangles. You have to look for the common side or the shared side. All right, other part, vertical angles. Again, you break off your triangle into two smaller triangles. Look which angle is common. Look to see which angle is common. So that's going to help you. Look at which angle is common for both angles. And then they'll tell you whether or not which sides are congruent or which sides. And then in a little bit, we're going to go down memory lane. Because I think we talked about it briefly last time. Midpoints and angle bisectors. That's going to help us too. The knowledge for angle bisectors, they're going to help us determine which angles are congruent to which other angles. All right, questions up to this point? I know a lot of this is going down memory lane. Again, it's good to remember because chances are midterm, final, we're going to be dealing with this stuff again. All right, moving on. Questions? Okay, and this last one, remember, parallel lines. Who remembers what type of angles we have going on here? It's two words, begins with an A. Anybody remember what type of angles we have going on here on the next page? Two words. First one begins with an A. And the second one begins with an I. Who thinks they know what type of angles we have going on for both cases? What's that? Oh, so what does so what's on the board? What are they called? Okay, so interior.
Alternate interior.
All right. Alternate. Good, it was on the board. That tells me at least somebody's looking at the board. All right. So yeah, alternate interior angles. That's a Unit 1, Unit 2 idea. So that's what we have going on. Now, here is where we're going to have to deal with more of those three-letter angles. Because remember, the three letters, they tell us our starting and ending point. ACD, CAB. They tell us where to start. You start at A, go to C, go to D. But similarly, from C, you got to go up to A, to B. That's what we have going on here. And then with CAD, ACB, same idea. You gotta follow. The order is like our roadmap. We have to follow where we're going. So you start at A, you gotta go down to C, then up to B, or vice versa. C, up to B, and down to A. Or D rather, CAD. CAD, yeah. All right, questions? Again, that order is going to matter. Have to get that order right, just like the congruence statement of our triangle. So, congruence statement, along with angle, what matters? Who can tell us what's going to matter here? Begins with a no. We just said it. I want everybody to say it. What matters? Begins with a no. Order matters. So, everybody. Order.
Order matters.
Order matters. Good. I'm going to be doing that more. All right. Now, this one. All right. I think some of our slides got messed up a little bit. What's time out? Did I put those slides in right? Oh no, I think I gave you the wrong one. Ew. Okay. All right, we'll be okay. What's on the next slide? I might have given you the wrong one by mistake. Oh, I skipped the slide. Okay, I skipped it by mistake. All right, here we go. Okay, sorry about that. I'm like, wait a minute. My slide's on right, but that's because I went a little too far. Sorry about that. All right. So does everybody see we were given angle R is congruent to angle U, right? Do we agree to that? So these blanks, we're going to start filling in some blanks. Get ready to fill some blanks in. And then they say from PRSU. Boom. Boom. Now, if we want to make this an angle side angle, so what they want us to do in the end, we want to have an angle side angle. So they first gave us an angle here. Then they gave us a side. So the way we get angle side angle P has to be congruent to angle S. So that's really the goal that's going on here. Angle P is going to be congruent to S. That's what we have going on. And going forward, that's what we're going to have to be doing for a lot of our... okay, go back a slide. Yeah, there we are. Okay, so see those blanks? We're going to fill in blanks. Okay, ready? Fill in those blanks, Captain. That's what we have going on. Okay, be careful. I'll tell you what's going to go down in a second. So you also have to look at what we need to fill in each of these problems. So this first one was for an angle side angle. You're given an angle, you're given a side. You have to give me that other angle. However, the next one's going to be a little different. And I noticed some of us were filling in blanks. Now with angles, how many letters do we need for an angle? 1, 2 for a side. Now, could we have 3 letters for an angle? Could we have 3 letters for an angle as well? Yes, you can. So how many? Okay. Christian, how many letters do we need to make a side? One or two? Or three? How many letters do we need to make up a side? For a side, how many letters or how many points do we need to make up a side? Okay, who could help him? How many letters to make up a side? We need how many letters? Two. 2 letters for a side. And then for angles, Zoe. 4. So 1 is good. 3 is the other, yep. You could have 1 or 3. All right. Okay, now this is why I noticed some of us, some of us are sort of right. There's going to be a P and an S there. Now, the only reason why this one's a little different from the previous one, because what did they give us first? What was given to us first? What did they tell us? Which angles were congruent? Look at our statement. So they told us angle R and angle U were congruent, right? We see that here? Then they told us angle P is congruent to angle S. Now, so they gave us an angle and an angle. They want us to get an angle side angle. So in order to determine, to get the angle side angle, what side do we have to say from RP? US. That's right. That's the goal here. So yeah, this would be, so yeah, even though that S for the sides is covered. And again, 2 letters are for sides. All right, questions up to this point? Now, on your test, you're going to get something similar. You're going to get something similar to where I'm going to give you 2. You have to look at congruence to give me the missing parts, whether if it's an angle or a side. And we'll do a few more of these. And then this was also good for us with that last homework assignment, where we had to identify what pieces were indicated. And we might try to do that on Monday. We might do a little review on that. I don't know if we're gonna have time to review that today. We might, I don't know. We'll see. Okay. Now, the next thing they want, I don't know why this is all, I thought I had fixed. That is an S for a side. Well, you'll also see it here. Side, angle, side. All right, they told us PR, SU were congruent. They gave that to us. We agreed to that. What else did they give us? What else was given to us? R and U are congruent. Now, we want a side angle side. So be careful. We want a side angle side now. So they first gave us a side. Okay, so you're saying, so which side should we use from the left triangle to get that side angle side? Okay, so RQ. That's your third side. And then what would be the second side? U to T. Or I should say, the side in the second triangle that corresponds. UT. Now, I think somebody might have said TU. That's okay, too. You can get away with it. I mean, you want to try to keep it as orderly as possible, but here you knew, okay, RQ, QR, that has to match up with UT or TU. All right, good job. You see, so does everybody see where we're going with these types of problems? So again, look at what's given, and then mark it on your triangle, and then look at what else you need to satisfy the congruence. So that's what labeling is key. As we label, we see we need side angle side. We had a side, we had an angle, so we need another side in order to satisfy SAS. Okay, questions? Okay, we need angle side now. So what's given to us first? What's given to us first here? Who could tell us what information was given to us first? Look over here. What's given to us first, ladies and gentlemen? What two angles are congruent to each other? T and Q, Q and T? Yep. All right, so that's an angle. We all agree that's an angle, right? Yeah. Now, what else was given to us? PQ and ST, what are they called? What are both of those things called?
Sides.
That's a side. Okay, now we need AAS. Now you could also say SAA. Oh, good morning.
Good morning.
Sure. I guess. All right, so we need the AAS. You could also go SAA. I would be okay with that. So now we need to figure out, so we have a side and an angle, we need another angle. So which angle, let's look at the left triangle. Which angle would work such that we would have AAS or SAA? Which angle? So look at the left triangle first. Why do you want to say R? Okay, so why do you want to say R and U, Valerie? Just want to make sure I understood you. Huh? Okay. You were good. Both cases you were good. Very well done. So you want to make, so it has to be this one here. Because in the end, you have your AAS or your SAA. Now, what if we had put it here? Would that work? If we had used this angle up there. Yeah, so that's why we couldn't use that. Very good. We couldn't use angle P or angle S. So we had to go with angle R and angle U. Well done. Again, this is going to help us. It's going to help us going forward. Regarding, especially when we deal with some of those problems where they don't have the letters, but they do have angles and sides indicated. Angles and sides are indicated, so that should be enough to where if we label, okay, I have an angle here, I have a side there. Then do I have angle, angle, side, or side, angle, side, or side, 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 all that fun stuff. All right, anybody questions? All right. So next one. For that one, so on the top, it's an R and a U, okay? And then you'll get the angle, angle, side deal. All right, we ready, everybody? Look at the next one. Let's make sure we have everything copied. If we don't have everything copied, then you're not going to get full credit for the assignment activity for today. And I think going forward, that's going to be an idea. Because you get grades with notes. So we have, not only we're taking notes, but we're being responsible. So going forward, there may be a time where I'm going to say, hey, complete the notes, you get a grade. But I think going forward, I might do it at the end. I might do it at the end of the period. I might say at the end of the period, okay, I'm checking your notes. Did you complete it, yes or no? But today, I told everybody right away, I'm going to check. So, all right, on we go. Okay, side, side, side. This one's going to be rather easy. They gave us DE and RS. Okay, notice the order. DE, RS. Oops. And then they said D to A, R to Q. Now, well, this one's rather easy. We want side, side, side. So you have to give us, so we need a side, so we can figure out what side on the left triangle is congruent to what side on the right triangle. Who can tell us? Say it again. EA. Actually, I should have. I'm marking it blue. EA. That's cute. That works. Now, if Des had said AE and QS, would that work too? Yeah, I'll give you credit for that. Yeah. Thank you. Yeah, that's acceptable as well. Because as long as, I mean, we want, I know with the triangle congruence, we're going to keep it in order. But if you had just flipped it immediately, given the direction of the triangle, all right, I'd be okay with it. So I'm down with that. Okay, questions. So again, look at what's given. Look what you need to complete that last part. If you need a side, an angle, or whatever. I'm giving everything else. But again, mark your triangles. Mark what's given to you. Because that's going to help you determine the last part that you need. All right. Questions before we continue? We'll do a couple more, and then we're going to talk about something else. All right? Some new stuff. Now, the next step I wanted to do this way, and we kind of seen this one before. So we said PE and RE. Oh, that's wrong. Okay. I made a boo-boo. That should be PE. Change this on your paper, please. If you haven't done so, yeah, just cross out PR, make it PE. Cross out SU, make it RE. I forgot. Everything else should be good, though. So This might be a problem where you might have to break it down. You might have to break this one down into two smaller triangles. Now the goal is we want our side angle side. So, well, what's given to us first? So if you want to break it down, you can. Okay, so PEF, F, E, R. All right. So they taught us PE and RE. So what do we have right away? So we first have A with the side. What else was told? An angle. So remember PEF. Remember, there's your angle right here. You got to start from P. And in this case, we have to use all three letters. We can't just say angle E, because then is it this part of angle E or is it that angle E? In this case, we have to use all three letters. That's why going forward, that map. Think about it like a map. REF, you start at R, go up to E, boom. So they gave us a side, and they gave us an angle. So what's left? Well, what do we want? What's our goal? And yeah, we want a side. So what side? Well, be careful. If we put the side here, is that SAS? No. What's that? We already got it. PE we already have. So we can't, so PE is already there. PF we can't use, because if we use PF here, and RF, that's not going to work. Because you skipped an angle, and you skipped something else. But what else could we, what's an easier one? Say again? EF. Why is EF the easier one? What do you see in both? What side do you see in both triangles? If you split this into the two smaller triangles, what side appears in both triangles?
E and F.
E and F. That's right. So this is sort of like when we talked about the shared side. Boom, there you go. What's that? Yep. And we're going to talk about this momentarily. That's an example of a shared side. And they call this the reflexive property, which I'll talk about briefly in a little bit. We'll talk about this in a little while. Because what's going to happen with the reflexive, basically, you're setting something to equal itself. The only reason why we're going to say it's congruent is because the EF is in two different triangles. That's the only reason why they're going to say reflexive. Because if you say something is the same thing as itself, reflexive. Now, it might be like, okay, who's heard of a reflexive verb? Either English, I know in Spanish they have reflexive verbs, right? Like, I'm just going to throw an example, like, okay, or something that's done to itself. So they're saying this side is equal to its own self on its other side. All right. Sorry about that. I know I'm going way off target. Okay, questions though. Again, the key. Look at your triangle congruent statement and look how you have to prove it. That's what they're going to tell you to do. I think we have one more of these, and then we're gonna definitely talk about new activity. Let me see. Yeah, all right. We got one more of these, and then we're gonna talk about something new. All right, this is the last one. Now, this one you can kind of get away with a single left. Oh, maybe not. Oh, I wrote this wrong. No, I didn't. I'm sorry. What I should have done, this needed to be the box. No, there isn't. Let's get rid of that. Very good. Okay, well, that's what I get for doing this.
And there's no ST either.
Yep. PQ, so this is what I mean. Everybody's paying attention. Let's get rid of PQ. Let's get rid of ST. Cross those out. We're going to make that EF. So PQ, that's now EF. So please, ladies and gentlemen, make that change. And this I'm going to be looking at with notes too. I'm going to be looking to make sure you're making these changes. And then ST is going to become JH. And then I should have said, yeah, I made another one. I forgot to say what type, AAS. So, yeah, this slide was very incomplete. So we got to prove it by AAS. But this one's going to be easy. You know what? I'll give it to you because what happened was this was a messed up slide. So FGE is this angle over here. And then HGJ is this one over here. But what do we know about, well, they're shared angles, but what do we know as well about the measurement of those two angles going directly across? What type of angles do we have? Begins with a V. Vertical angles, very good. So the vertical angle is going to be like a shared angle. So that's a way we can say these two angles are congruent. So they gave us this one. Then they also, well, after our mess up, they also said this was congruent. But now we need one more thing. Well, we have G already. Because the goal is we want AAS or SAA. We want AAS or SAA. So what will be the other one? That's all right. All right. Look at our two triangles. What do we know about angle E and angle J? What do we have going on there? E and J. Okay. What else do we see with angle E and angle J? Look at the arcs. How many arcs do you see for E? One each. All right. So this is where we get the A. Boom. Boom. Even though they're in opposite directions. Notice E and J have one arc. Now, in the end, I kind of messed up on this one. You know why? Because what should have happened, I looked at this problem now, I realized I should have given you these two. Then you get the other angle. Yeah, I did this example backwards. So this is kind of my fault. Because in the end, these two should have been given. These should have been the one we needed to discover. Because the goal in the end is, everybody needed to see these two angles were congruent. Like this one right here, this one right there, they were congruent. Because they're vertical angles. And then we would have had the AAS or the SAA going that way. So that's my mess up. Okay? So we go this way or this way. Because this angle is automatically going to be congruent here and here. They're vertical. And then we notice you go down to J or go up to E. Those angles are congruent too. So there's your A, and then we said this side was congruent to that side. That's how we get the AAS or the SAA. Yeah, this was a bad example. So, okay, did we get that last one? Did we get that last one? I just want to make sure we got it. All right, questions. Now the next set of things, we're on that memory lane. And then, depending on what else we get done. So the next set of slides, that's all memory lane. I'm going to tell you that right now. There should be no... let's see how much more we have. We don't have a whole lot. It's not as long as we think. All right. 18. Okay. Previous rules. We should know these rules. Vertical angles are congruent. We just talked about it 2 seconds ago. Also, linear pair is supplementary. You have your linear pair going this way, or you have it going this way. Either case, what was the sum of those two angles always add up to be? 180. So these are going to be previous tricks we're going to be using again. Similarly, alternate interior angles. They're going to be congruent because we're going to tell you with some of these diagrams, like your parallelograms, we're going to say those sides are going to be parallel. Or these sides might be parallel. And that's going to help us, especially if we have a third line going like that. That's going to tell us which angles are congruent to each other. So all that stuff we did first quarter, that's coming back. And we're going to see this again, probably third quarter. So that stuff that we learned in first quarter, especially with the angle identification, we're going to see that again and again throughout the rest of the year. So angle D, which angle? Okay, I'll give you that. It also works. A and D would be congruent. All right, I'm not going to say no. Or E, yeah. That's what, I mean, you're right. A and D are going to, so I can't say you're wrong because you're not. Yeah, this one, it was more the purpose with the alternate interior. But yeah, that's why I can't say you're wrong because you're not. Angle D and angle A would also be congruent. And then E and A, they would be corresponding. So yeah, that's some good stuff. Yeah, you remember all of that. So yeah, that would work too. Yeah, but this one, I just want everybody to know what the alternate interior. So similarly with C, what's the alternate interior angle to C? Is F. But yeah, you weren't wrong when you said all that other stuff. So yeah, A, D, E, and H. Remember the Charlie Brown method, the zigzag? You know how he has that zigzag on his t-shirt? So yeah, our buddy Charlie Brown's coming back into the game today. Yeah, same thing. Yeah, B is C, E to F, and then F to G again. All right, questions? Anybody else questions on this part? So again, this is stuff we've seen before. We're going to be seeing again. Now, another thing we're going to see again is a combination of both an angle bisector and segment bisector. This one's going to be super important. I'm going to tell you why. Because when we start dealing with them bow tie problems, you know the ones that look like this? They're going to say that point is going to be your midpoint. So if it's a midpoint, they're going to tell you, the midpoint says, okay, the sides are going to be congruent to each other. That's what you're going to have going on here. So that midpoint, the segment bisector, or the midpoint, they're going to tell you what that's going to help us determine which sides from one side of the triangle or the figure is going to be congruent to the other side. So you remember the midpoint from back in the day? That's segment bisector or midpoint, beginning of the year, midpoint. Right in the middle. Two sides. One side left or above, same as below or to the right. So welcome to that again. Okay. Bye-bye music for now, please. So that's another rule to remember. And then, of course, perpendicular bisector. Remember, think of a mirror. Perpendicular bisector, that's your mirror. Boom, that's your mirror. That's your mirror. That's the way to think about it. Boom, mirror. Because in the end, once you set up your mirror, perpendicular bisector, both of these triangles are what type of triangles? They're going to be right triangles because you got a right angle. And then that's going to help us because then we have several ways to prove that this triangle is going to be congruent to that triangle. We have several ways to prove it now. So when you're going to have a side angle side, or hypotenuse leg. You got three ways to prove that triangle. Those two triangles are congruent. All right, any questions? And then the last one, we just talked about, we spoke about it briefly. The reflexive property. So something is equal to itself. So here, you kind of have that going on here. So we talked about it briefly where the side that is shared. Basically, if we broke up this figure into two smaller triangles, So again, we kind of seen the reflexive property already. It's the side that is being shared in both triangles. So when you break up whatever, your bigger triangle into two smaller ones, or you break up your parallelogram into two triangles, the reflexive, that's basically the side that shares itself. That is, you see on both. So you see it in both. All right. Questions on new stuff? Hurry up. Be there and back. Whatever you missed, get from a neighbor. They're going to be coming around and checking to see what we have. All right. All right. Anybody questions before we move on? Again, a lot of this is memory lane stuff. And then this is new, but we kind of already saw it. All right. Let's see where we are. Okay. All right. Now, these next few. Okay, these next few we're just going to basically break down what type of triangle congruence we have. So right away, so for this first example, they said AB and CD were congruent. So if you want to break this down, you can do that. You can break it down into two smaller triangles. Does everybody see what we're doing here? We're going to break this bigger figure. We're going to split it apart. So that's what we have going on here. We're going to split this. We're going to split this one apart. You have that was not what I wanted to do. Boom, boom, boom. Big. And what's that? Okay. Whatever you miss, get from a neighbor. Whatever you miss, get from a neighbor or something. All right. So they first gave us AB is congruent to CD. Well, AB and CD are both what? They're both. Yeah, but not only that. What else are they? Congruent gives it an S. What's that called?
Side.
That's a side. You got a side here. Then they said BC was congruent to DA. Well, what are these called? What's this called? Or what are they called over here? That's a side too. You got a side, side. Now, they said AC for this triangle was congruent to AC. Now, some of you might say that could be CA as well. That's fine. If you flipped it. But in the end, we can say that's the shared side, right? So it's going to be congruent for both triangles, yes? So in the end, we have a third side. Now, do we have enough information to say these two triangles are congruent? We do. Can we say congruent triangles with side, side, side? There you go. That's how we're going to be doing some of these types of problems. That's a side, side, side there, ladies and gentlemen. Because the first two, we saw that they were congruent. And since both triangles share this side, that's also going to be congruent. So that's just a side, side, side right there. So going forward, we have to look at what's given to us. And then that's going to help us determine who's congruent to what. All right, questions on what we're going to be doing for the next few minutes? All right. All right, next one. AECE. What is that called? AECE, they are both what? They're both sides. What about AB and CD? They're also sides. So I should have done 1 and 2. Now, they told us E, that's the midpoint between B and D. That's what they gave us. So if E is a midpoint between B and D, what's that? Okay, well, okay, you could say that, but if this is the midpoint, what do we definitely know about the distance from B to E and the distance from E to D? They're going to be congruent, that's right. That's a midpoint right there, ladies and gentlemen. Boom. That's because that's a midpoint. Yeah, that's like midpoint. That's a bisector, or segment bisector. Now you can say midpoint segment bisector, but again, BE, DE, they are both what? Are they sides or angles? BE, DE, sides or angles. What do we have there?
Side.
That's a side. So in the end, let me write that over here. Let me write the S's over here. Side, side. Well, can we now say these two triangles are congruent? Why? All 3 sides. That's the game plan here. Boom. Side, side, side. Bang. There you go. Because the key is, because I know why you wanted to say the angle. And technically that would work there. But here, the midpoint, we want to say this was the midpoint because we can get sides. But we can't do a side-side angle. We can't do that. But we can do side-side-side. But I'm glad we're saying what we're saying. All right, couple more. What about this next one? Okay, so they said that these sides are parallel. That's going to help us with something down the road. Because if these lines are parallel, AD and EC. Remember, those lines are going to go forever and ever. That's going to help us with something in a minute. Then they gave us DD, DC. That's it. So they gave us a side right here. You can't mark this as a side necessarily. They're just saying these lines are parallel. They're never going to touch. That's going to help us with something in a minute. So then they said BD, BC. That's a side. Now, angle D and angle C are congruent. So they're saying these two angles are congruent. But why can't we say D and C are going to be congruent angles? Who thinks they know why? Who wants to take a guess? Actually, all right, let me draw it a different way. What's that? I'm going to draw this another way. I think it's going to be a little easier. All right. How about if I draw it like this? Boom, boom. Then I'm going to say this. I don't like that one. All right, all right. No, I put it in the wrong spot. Okay, I see where I'm going now. That's angle D. And this is angle C. Here's another way I want everybody to see this. What do we have going on there? Or, let me rotate it. I'm going to rotate the bow tie so it looks more like this. Pretend that's your bow tie. There's D. There's C. And these are parallel. They're going to go forever and ever. What can we say? Let me take this out. What type of angles can we have there? Give you a hint. Gets with an A. The first word's an A. Alternate what?
Alternate interior. Interior.
Interior. Okay, that's going to be a rare case. This one was a little hard. That's why I wanted everybody to look at this together. But that's the reason why these two are going to be congruent. That's going to be an alternate interior. So I should have said, now, this is the one where actually we should have been careful. What I should have said, no, I couldn't have really said it. All right. So that's an ankle. We got side. Ankle, side. Now, that last one. What do we know about these two angles right here? So, okay, we'll say these are alternate interior. And this is just more connection. I just want us to make the connection. What can we say about the last angle? ABD, which is here, and C, or EBC. What can we say about those two angles? What do we know about the relationship of those two angles that we just marked here? What do we know? How do we mark those? What do we know about the relationship of those two angles going across from each other? Begins with a V.
Vertical.
Vertical angles. Now, the reason why I wanted to do this diagram, be careful how we say these two triangles are congruent. Don't always go by what you see here. Go by what you see in the figure. Because a lot of us, we see this, we're going to think it's SAA. We're going to think it's SAA, but is it really SAA? Can we say SAA, given what we see here? Can we do that? Look at your figure. Look at here. Can we say, is it SAA or ASA? Which one will it be? Look at your diagram. Look at your diagram. Look how where the A's and the S's are, how they're ordered. What can we say?
ASA.
It's going to be ASA in the end. That's right. It's actually going to be ASA. This. Now look at your figure. Look at figure. Look at the figure. They say ASA. Now, when you take your test, I will make sure it's going to be usually in the order. Order how you see it, that's how you're going to write. This one, we had to use we got to play a little game or two here. But yeah, this one in the end, that's going to be an ASA. You get the angle, the side, and the angle. That's how they will congruent to each other. So be very careful with that one. If you need to mark your triangle to help you, that's fine. Okay, questions? We're gonna do one more. And then, again, those last 4 slides, we're gonna just, not gonna talk too much about that CPCTC business. Not gonna talk too much about it at all. All right, last one. This is where angle, midpoint, all that fun stuff is gonna be related. So they said O was the midpoint of MQ. And O is the midpoint of NP. So, if O is the midpoint of MQ, what can we say about the distance from M to O and O to Q? What can we say? They are congruent. MO, OQ. That's midpoint or segment bisector. So either one, I will give it to you. And what about NO and OP? O is midpoint, so what can we say about these two? They're also going to be, it doesn't, but don't always go by what it looks like. Go with what they tell you. So I know, and trust me, they're gonna do that all the time. You got a good point. OP and O does not look like they're congruent. But go with what's here. Sometimes the figures are not they're gonna look different, but you gotta go with what's given to you. So they're telling you that's the midpoint. So then NO and OP are also, they're gonna be congruent. And you can say the same reason. Midpoint segment bisector. So 3 and 4 are going to be the same exact reason. Now, so right now we got a side. We have a side over here too. Now, why would angle MON be congruent to QOD? Who can tell us why those two angles are going to be congruent? Begins with a V. Vertical angles. Vertical angles. That's right. Again, it doesn't look it, but they're the vertical angles. So now we have an A. So now go back to, so okay, go to the figure. So even though it was an A, but why would those two triangles be congruent? Again, don't go by how you list it. Go by the figure. Look at your figure. You can tell us why they're going to be congruent. What congruency? Look at your figure. That's going to be the key. Okay, so where's the angle located? Is it between the sides or is it away from the sides? So look where our S's are. We got a side and a side, but where's that angle located? Is it between the two sides or is it before or after? Where's it located? Where's that angle located, ladies and gentlemen? Is it, okay, Zoe, is that angle between the sides or is it not between the sides? Look at our figure. Look at our figure. Over here, ladies and gentlemen, where's that angle located? It's at the midpoint. So, is it located between the two sides? Okay, so in the end, would it be SSA or SAS? It's going to be SAS. You cannot do SSA. SSA is not good. is SAS. All right. Okay. So again, I think we're at that point where go by the figure. Go by figure. Go by the diagram. Actually, I should say diagram. It's probably easier. By diagram. Don't go by this order necessarily. Go by your diagram. All right. Basically, what's going to happen now, the reason why I don't really want to talk about that CPCTC stuff, basically is once you put the triangle, then what's going to happen, you can say all the other corresponding parts are going to be congruent. Basically, because if we look at the diagram with that CPCTC, once we prove this part, then we can say corresponding parts are also going to be congruent. That's really what's going on here. But yeah, so after you prove the triangle congruent, then you can say the corresponding parts are going to be congruent as well. But I'm not going to go into that because I'm not going to put that on the test. But it's just more for future reference. What I am going to do in the meantime, so in the last few minutes, all right, I'm going to pass around the study guides. You all get a heads up. We'll take one, pass them, pass the others back. Oh, yeah, give them to Zoe and Valerie. And then Edwin. Take one, pass them around. All right. The few minutes that we have left. Go in. Oh, I think, all right. Yeah, Andy got one. Thank you, Dez. Okay, so what we have going on will be the following. I'm going to bring that up real quick. All right. I apologize, I really wanted to cover more of this, but this is all we're going to be doing next time. So, really quick, basically the first couple slides are just rules. Definitely know these rules. These rules we're going to see, we've been seeing in and out. Same thing here. A lot of these rules are going to relate to each other. The only thing I forgot to mention, no, actually I did mention it back here. Linear pair, sum of your three interior angles, right angle. And then angle measures as well. And then also the relationship, two angles, add them up, and it'd be the same as the exterior of the third angle. And I'm just going to do a quick rundown. Now, some of these, you're going to just do sometimes as simple as matching. But you might also have a couple slides are just matching up. Look at your definitions. You should have them at the beginning. Check your notes. That's more beginning. And then same thing. So the first three, you're matching up with what's given to you. And some of these print out sides or angle measures. Again, look at what's given to you. Here, you're finding the missing angle measure. Now again, what must the sum of the three angles add up to be? 180. That's going to be K. That's right up here. Again, this one. To get this last angle, what must we do to the other two angles?
Add it on Find the last angle in the triangle.
You could do that. You can find this last angle, and then these two have to add up to 180. What else could you do? Regarding just these two numbers. What can you do to these two numbers to get that number? Just add them up. Yeah. You can do that too. Add them up, bang. Because in the end, these three all have to add up to 180. But x plus whatever's here also has to add up to 180. So in the end, you can just add those two up, bang, you got it. Now some of these are going to be a little hard. Yeah, this one's probably going to be the trickiest because, again, vertical angles are going to be the key. You may have to do these back. You might not be doing these. All right, and the rest, we'll talk more on Monday. So try to start working on this. Try to start working on this. That's going to be your homework.